Space is a vacuum. It has no air, no molecules to carry scent. Therefore, space itself is odorless. Imagine a place with no flowers, no rain, no freshly baked bread. That's the olfactory reality of outer space. Our noses rely on molecules to detect smells. In space, the absence of air eliminates this process. The vacuum of space ensures a scentless environment. It's a world beyond our olfactory senses. Astronauts, upon returning from spacewalks, often report a peculiar smell clinging to their spacesuits. This smell, described as a mixture of burnt steak, hot metal, and welding fumes, is a surprising contrast to the odorless vacuum they just experienced. The smell isn't from space itself, but from the interaction of high-energy particles with the spacesuit materials. These particles, remnants of dying stars and other cosmic events, collide with the suits, causing chemical reactions. These reactions produce the unique aroma that astronauts detect upon returning to the airlock. The spacesuits designed to protect astronauts inadvertently become collectors of these cosmic particles. When astronauts return to the pressurized environment of the space station, these particles release their distinctive odor. It's a sensory experience that bridges the gap between the emptiness of space and human perception. The smell experienced by astronauts is a direct result of chemical reactions. High-energy particles constantly bombarding the surfaces of spacesuits initiate these reactions. These particles, traveling at incredible speeds, carry significant energy. Upon impact, they interact with the molecules of the spacesuit material, altering their chemical structure. This alteration leads to the formation of new compounds, some of which are volatile and have distinct odors. The spacesuit material, primarily composed of various polymers and fabrics, plays a crucial role in these chemical reactions. Different materials react differently, leading to variations in the perceived smell. The spacesuit acts as a canvas, capturing the chemical signatures of these cosmic encounters. The scent of spacewalks is a valuable source of information about the universe. Polycyclic aromatic hydrocarbons, or PAHs, are key players in the creation of the space smell. These complex organic molecules are abundant in the universe, formed in the aftermath of stellar explosions and other high-energy events. When they come into contact with spacesuits during spacewalks, they adhere to the surface, becoming trapped within the fabric. Upon returning to the pressurized environment of the spacecraft, these PAHs are released, contributing to the distinctive aroma. Ozone, a molecule composed of 3 oxygen atoms, also plays a role in the scent of space. It's formed when high-energy particles interact with oxygen molecules present on the spacesuit. Ozone has a sharp, metallic odor similar to the smell of welding fumes. The combination of PAHs and ozone creates a complex aroma, a blend of burnt, metallic, and sometimes sweet notes. The scent of space is a tangible link to the vast chemical landscape of the universe. Astronauts have offered a diverse range of descriptions for the smell of space. Some liken it to the scent of seared steak, while others describe it as hot metal or welding fumes. Don Pettit, a NASA astronaut, described it as a rather pleasant, sweet metallic sensation. This variety in descriptions underscores the subjective nature of smell perception. Each astronaut's olfactory system interprets the complex mix of PAHs, ozone, and other compounds differently. Astronaut Thomas Jones compared the smell to walnuts and brake pads. Peggy Whitson described the smell as distinctly metallic, kind of like burnt almond cookies. The varied descriptions from astronauts paint a picture of a complex and unusual aroma. The smell of space becomes a personal experience, unique to each astronaut. The phenomenon of space smell isn't limited to spacesuits. Other celestial bodies and regions within our galaxy also possess unique chemical compositions that contribute to their own distinct scents. For example, Saturn's moon Titan has an atmosphere rich in hydrocarbons, giving it a gasoline-like smell. The molecular cloud Sagittarius B2, located near the center of the Milky Way galaxy, contains ethyl formate. This compound is responsible for the sweet scent of raspberries and rum. Comets, icy bodies traveling through space, also contribute to the cosmic olfactory palette. As they approach the sun, they release a mixture of volatile compounds, creating a unique aroma. These examples highlight the vast diversity of chemical compositions in the universe. The universe offers a rich and varied olfactory experience waiting to be explored.